In this tutorial, we'll look at and explore the concept of planes of motion. So planes of motion is a very accepted definition, or certainly kind of teaching philosophy used within kind of teaching, really kind of the idea of kind of the various movements or the directions or the orientations that humans can move. And is also used very much in, say, 3D motion capture and things like force plates and pressure plates. The way of defining the direction or the orientation, the translation of the segment as it moves through space. So using these examples on screen here, you'll see we have very much the anatomical axes or anatomical planes of motion. So the idea of the coronal plane, or is it sometimes called the frontal plane, which is almost the kind of lateral side to side, or the medial lateral kind of sway value in some ways, as it could be related back to, say, the 3D world, or say force plate definition. We then have the sagittal plane, which is the forward and backward, or the bending, extending, the flexion extension plane, and then the transverse plane, which is more that kind of rotational, almost as I kind of sit here, that rotational plane of movement. So there's three defined anatomical planes of motion: the frontal plane, the sagittal plane, and the transverse plane. And it really helps us define how segments rotate and change positional translations, as they're more known within biomechanics. It really helps us explain what direction and how that segment, also what direction that segment rotates in around those three planes of motion. And even looking then at 3D motion capture, we use something called the Cartesian plane. The Cartesian plane being those three numerical planes we often use to describe and really define, again, the direction and orientation segments move at almost numerically and mathematically through swing. So for example, the z-axis is the up and down movement. The y-axis typically would be the forward and backward, so towards and away from the ball, and the x-axis would be along that target line. So we have these definitions of planes of motion, just going back once again: the anatomical axes, the transverse plane, the sagittal plane, and the frontal coronal plane. And then we have the Cartesian plane within, say, 3D mathematics: the z-axis, the x-axis, and the y-axis. However, the reality when looking at how humans move is we actually never really move independently along any of those axes, or rotate along any of those axes, independent of how any other segment moves through space. So the idea of kind of planes of motion, yes, it's a very good way, and it's an excellent way, and absolutely right way of defining, certainly at that kind of entry level. So almost I can say at kind of high school level or GCSE level in England, as it would be. So that kind of entry level way of defining planes, or certainly directions and how we move. But the reality is we are a spiral movement. In essence, we move along all three of those planes at every single point in time. So the idea of trying to move along one plane independently is simply a very inaccurate, actually quite unhelpful way of really kind of defining and almost kind of guiding and educating that kind of really expansive way of movement. So some examples we can look at here, for example, in a fun way, that the idea of kind of changing plane without control. So we're kind of always these interaction of these kind of planes of movement, plane literally here being the kind of fun word. How do we kind of interact and move between those planes to kind of produce movement? So even using some examples here, we have these tensegrity models, which are really designed by a guy called Buckminster Fuller way back when, and really kind of made famous by then a man called Kenneth Snelson. So these kind of tensegrity models really show more precisely anatomically how the human moves to produce rotation and position. So for example, if I shorten and move, say, as it would be in this case, along that kind of x-axis, or really then move along that kind of frontal plane here, you'll see how every other segment or bone or joint in this case orientates and changes position in a different direction. So the idea being that, yes, we say move along the sagittal plane, as it would be, or the frontal plane in this case, along that kind of x-axis, is also then creating rotation and a change in position in all other three directions. So then even using a sort of a live example of the Cartesian plane, red would be defining the x-axis, green would define the y, blue with the red. We never actually move like this ever through at any stage in the goal. So the reality is this is more so how humans move through space. So we're having that continuous change of both position and orientation, actually in both directions. So actually showing a video now of how two cogs move. This is actually more the reality, that as one joint moves, say, into external rotation, the opposing connecting segment, or that actual internal structure within that joint, actually then move into then internal rotation. So we are these combination of internal or external rotations that happen bilaterally. They're binary movements that happen in duality to produce those wonderful rotations that we see. So yes, for example, the pelvis may move, as an example, into external rotation or clockwise rotation through backswing, but it's the interaction of internal external rotation which is actually producing that rotation through space, which is really shown wonderfully well by these two cogs. So both the cogs to move, in essence, they have to move in different orientations and in different directions. And we can really start to apply that more kind of precisely now to the golf swing. Say, for example, we mentioned the pelvis and hip joint there. So looking very accurately now at how the trail hip would move in transition. So as the pelvis, so for a right-handed player, so for left-handed players, invert this. So for a right-handed player, as the pelvis starts to move in that very visible, very tangible anti-clockwise or counterclockwise, or starts to rotate in that open direction, as it would be no more through kind of golf colloquial definition. The reality is that trail hip is moving through that three-dimensional rotation. So for the pelvis to move in that anti-clockwise way, the trail hip's moving into external rotation, it's also extending, and it's also moving into levels of AB abduction, because the pelvis is in essence moving away from that femur to allow the pelvis to glide laterally and move what would be known almost along that frontal plane. But the reality is, it's that three-dimensional movement. The change in position of that pelvis is happening in all three planes, in all three directions simultaneously, as that hip joint moves through, once again, that three-dimensional range of movement. So the idea of the trail hip moves into external rotation, it moves into extension, and it also moves into AB abduction, which allows the pelvis to glide and move away from that trail femur. So the concept of really producing one type of movement, one plane of movement, is simply not true. It's that wonderful spiral which we'll use when we look at this animation on screen shortly. And certainly when we look at some real-time segment passes we'll come on to as we move through this tutorial. We are this continuous spiral. We are a spiral system made up of multiple different spirals. That's the reality of human movement. So we move along all three planes in all orientations, in all different directions at the same time, rather than the idea of X, Y, Z, medial, lateral, posterior, anterior, horizontal or vertical direction. Sorry, in this case, it's a very easy sell to describe movement in that way, but it's a very, very inaccurate, and for me, a particularly kind of almost elementary way of looking at human movement. A much more advanced way and a much more precise, accurate way is to always see movement as a spiral, and then in many ways look to really define, is there a dominance or an imbalance? Are we moving in a very dominant direction rather than that wonderful continuous spiral movement we have through space? So often when we see imbalanced movement, it's because there's a dominance in one direction and almost a reluctance, a constraint then to move in the other consequently different directions. So XYZ is a very, very good way of selling. It's a very, very kind of easy way of understanding movement, but it's actually quite an unhelpful and in some ways a very inaccurate way of understanding movement when we actually look at those wonderful spirals that we have. As an example, using the wrist now, I can move the wrist into ulnar deviation, which in some ways would be the sagittal plane. I can move the wrist into flexion, which in many ways would then be rotating around the transverse plane, but then inside that joint intrinsically, when I go into ulnar deviation and flexion, my forearm also supinates, which would then be around, in this case, the frontal plane, or as it would be defined by the 3D world, then the y-axis. So when we look at that once again, for me to move what would be almost visibly in two directions, ulnar deviation and flexion, there's also a third response. My forearm then starts to rotate intrinsically into supination. So to move the wrists are three-dimensional moves. We cannot ever look at one direction independent of how the other two are moved. So very much like the hip joint, it's a three-dimensional interaction between the rotations, the counter rotations, and the changes in position. And it's very, very similar to the wrist once again. If in this case we go into radial deviation and extension, intrinsically my forearm then moves into a pronated position. So it's that three-dimensional movement. And again, to produce pronation through the forearm then creates counter rotation in the opposite direction through the elbow to allow then that pronation to happen. Really very much going back to the kind of two-cog philosophy. So really what can we start to extract from this already? X, Y, Z, or planes of motion. It's a very, very clean, very defined, kind of almost elementary way of looking at how segments move. But the reality is we are a continuous spiral that moves in every direction in those counter directions, the two-cog philosophy again, to allow movement to happen. Really what we need to really establish and look more precisely at is there a dominance in one direction, and is there a reluctance and a constraint to move in another direction, and then really start to look more in a much more kind of expansive, much more global ways to then really start to understand why. Is it more through concept, more through anatomy, more through the environment, more through our belief systems, whatever it may well be, that then creates those imbalances in how we move and swing. So even now using this animation on screen, playing this video through, you'll see that as we move back, how we produce this wonderful spiral movement through backs and that very expansive spiral. Then as we start to move down, we then start to compress to produce rotation. So the reality is how we move to produce rotation and force is a three-dimensional spiral of counter rotations, segments moving all different directions, rather than seeing movement as that very linear, almost non-binary approach to movement. It's much more reality based on this is how segments move to produce space. They're moving in different directions with those rotation, counter rotations, those binary movements in many ways to produce these wonderful spirals through swing. And actually then looking at that in the goal swing, so using this 3D animation, very much the cloud view as we see here. So actually now plotting the three-dimensional segment path, so the origin, the middle of the pelvis and the thorax. So we move this player into backswing now. You'll see that as we move back, so we'll let this player move back to roundabout when the shaft is parallel. And you'll see on screen now, we just pause it here and place two arrows on the screen. You'll see here that two paths are now being drawn, the blue plots, which represent the three-dimensional origin, how that segment moves, the path it moves on as it moves through space. We just remove those paths now and continue on into backswing. You'll see that as those blue paths are drawn, blue defines and represents backswing in this case. At no point is it in a very linear direction. That path is rotating and moving in that very spiral, circular way to allow that pelvis and ribcage to move and position and rotate, and also then produce force and expand through backswing. So if we take this back to the top of backswing, you'll see then when we actually look at the interaction, the connection of those segments, they've actually produced rotation, they've produced changes in positions in a very, very different profile. The blue plot of the pelvis is relatively flat. There's a little kind of peak up and downwards, whereas the blue plot of the ribcage is much more of a curve in that counter-clockwise direction. So very, very different profiles. When we interact and connect those segments, again, it almost goes back to these tensegrity models, these spirals that we have. At no point, any time in space, when we move this human through space, are any of those segments moving independently along and very much purely along the XYZ or the frontal, sagittal, or transverse plane. Is the interaction of the three. So then moving into downswing, you'll now see as the player starts to move into downswing, now two purple paths are being drawn. So once more, just to reposition those arrows once again to define those paths. The purple path here shows the three-dimensional path of the ribcage, and the purple path you'll see here shows the three-dimensional path of the pelvis. So we just now move this player furthermore into downswing. Again, very different profiles. That when those lines turn pink is where impact happened. Very different profiles of movement. The rotation, the orientation, the position, the translation of each segment are moving very differently to produce that wonderful interaction between how that pelvis and ribcage move to produce force and rotation through. And going straight to the impact position, you'll see how differently each of those segments have moved through space. So in that wonderful kind of curve, that wonderful kind of spiral shape to produce both rotation and force. So really, what can we learn and extract from this? So the idea of the Cartesian planes of motion, it's a wonderful way, in a very, very helpful way, of just almost giving that initial entry level to the direction that segments are moving in and the direction or the orientation, which direction they then rotate in through space. The reality is, really at no point is seen to be ever move independently along any of those axes or rotate purely around any axis. To rotate around almost the negative direction of the Z then creates counter rotation in both directions around the X and the Y, and vice versa. When one segment moves in one position, invariably then another segment goes in a different position to produce this wonderful spiral movement. So a much more, I think, accurate, a much more defined, and a much more expansive way of seeing is we are a spiral system made up of many spirals. So all times in swing, we're moving in every direction in these rotation, counter-rotation directions, very much as defined by the cogs showed earlier in the tutorial. Often when we have kind of almost imbalances or problematic movements within how we move in the goals, is because there's a reluctance or constraint to move in one direction, which then creates a very overactive dominance in a different direction. But even then still, It's still that kind of spiral we have, just in a much more adapted, almost problematic way. So planes of motion, very helpful, certainly a very great way to start to understand how we move in swing. But using these animations on screen and the slides that we shared today, seeing movement more as a spiral, that continuous fluid spiral. It's a bit like water in some ways. Water is that continuous movement we have, that regardless what kind of objects in the lake or the pond or the river in this case, water will continuously find ways of moving around that water to continue us on that path and move energy through the system, which is a bit like the golf swing. We are very much like rivers. We continuously move and kind of move around those rocks in this case. Rivers aren't X, Y, Z, up and down, forward and back with side to side movements. They're that wonderful fluid system that we have, which in many ways is the human body, because we are made up of almost predominantly 90% water.